Hi, everybody. Let's pick up where we left off when we were talking about alternative energy. And this is an example of some, obviously wind turbines. And many of you have seen these in action. They're kind of fun to watch. At least I think they're very cool to watch. And so let's talk about wind energy. And so wind energy is obviously considered to be an alternative energy, meaning that it is not actually part of fossil fuel using, and so we don't need to use fossil fuels when we have the wind available. They spin, and they don't turn really fast. These blades are really large on these, and it requires just an average wind speed of about 13 miles an hour. Use of that has grown, and lots of new places are adding wind farms to their list of things to use to obtain electricity from. Right now, it's on a trajectory to generate about 20% of the United States energy supply in the next 10 years. So by 2030, right now it's only supplying about 3% of the nation's electricity. So I have several embedded YouTube videos in this lecture, which you can find on Canvas. And I'd really like you to watch those because it makes it so much more interesting when you can actually see some of these things in action, and you can see how they actually work. There's a beautiful wind farm array. This is actually in Palm Springs in California, right on the edge of a cliff, and this is generating a tremendous amount of electricity for that area. So there are a lot of advantages, right? It's clean, it's perpetual, the wind is always going to move. The cost of these will likely continue to decrease quite a bit, and they have certainly in the last few years. The cost has come way down. There are a few disadvantages. One, the wind is intermittent and it varies, right? So if the wind isn't blowing that day, then you have all of these wind farms just not doing anything, and that's a big investment. Not everywhere has a steady enough amount of wind to actually become usable, and so it's not available every single place. They are expensive to install and very expensive to maintain, basically because of lightning strikes. I'll show you a picture of that in a minute. And there have been reports of bird and bat mortality at wind turbines. And then lastly, aesthetics. People sometimes don't want to have a view of a wind farm. They want to have a view of a mountain range or a view of an ocean, and they don't really want to be looking at those turbines. Although I get actually mesmerized when I watch them. So lightning strikes are very expensive. These are very complicated computer controlled pieces of equipment. They're all metal, they're sticking up in the air, and so they are prone to be hitting by lightning. And lots of times it won't just be one, because they're in rows. Lots of times it'll end up taking out several of them all the way through. There are problems with bats and birds dying in association with these. So originally, birds were being struck by these, and when I say they were being struck by them, they were running into them. Especially, these blades are huge. They're usually painted white, and if the bird is flying, so it's only seeing the edge, it might not see the actual turbine until it's too late. So when this was happening originally, there were quite a few things that were tried and have worked pretty well. Most of it involves noise or light or some other kind of reflectors, so the birds can actually see them, and they've pretty much been able to manage for that. So not very many birds are being hit by these turbines anymore. The bats is a very interesting thing, and this is the YouTube video that I would really like you to watch. Be able on your final exam to explain to me what was happening with the bats. And I can tell you, you know, if we were in class discussing this, I'd let you come up with a solution, but I can tell you what that solution was. The solution was they turned the wind turbines off now at night. So bats only fly at night. And so usually the wind immediately drops at sunset when the wind isn't helping to contribute to the temperature change, which causes the winds. And so they just simply, in areas where there are large bat colonies, and this is an issue, they just simply turn the turbines off at night. And so that was, you know, kind of a compromise. It wasn't too much of a compromise because they don't really generate very much wind at night anyway. But that was a solution to what was happening with the bats. But I still want you to watch the video so you know what actually happened to the bats. It was not that they were being hit by those blades. So please watch the video. So when people first started noticing all of these mortalities, and they were upset about it because, you know, this was supposed to be an alternative, a green energy solution to this. And there was a lot of complaints about it. And at that time, they pulled a lot of data in about bird mortalities and issues. And I thought this was a very interesting graph. And so very few birds are actually killed by these wind turbines, or were ever killed by these wind turbines. A lot more, this is per 10,000 fatalities for birds, are killed by cell phone towers and TV towers and radio towers. You don't hear people saying to take those down, right? Because everybody wants cell phone and radio and TV. A lot of birds are injured by being either directly sprayed by pesticides or after eating insects that have been sprayed by pesticides. Vehicles, I don't know anybody in our class, if you've ever been in a vehicle and you've either struck a bird or almost struck a bird, but it's not that uncommon. Household cats, a lot of people don't keep their cats indoors, they let them roam, and cats are notorious for killing birds. And then all the high tension power lines, birds again don't see those wires and can easily run into those and be killed. And lastly, running into buildings and windows. And that is a big issue for birds, especially if there are large glass windows. They don't actually see them, or the window is like reflecting the area around them, the trees and the branches, and they don't know that there's a window there, and they get struck. They fly right into the windows. That happens quite a bit at my house, especially in the late fall like it is now, and early spring. If the sun is at a low angle, it makes it difficult for the birds to actually see that. So if that has happened at your home too, or maybe where you work at, there's some easy things to do. One of the things that works really well is if anybody happens to have an old CD. People are like, I don't even know what a CD looks like. But if you happen to have an old CD, they are very reflective. And if you just tape up one of those in the corner of your window or let it hang in your window, the birds will be able to see that and recognize that there's something there. It'll catch their attention, and you might save some birds. So the result of this is, you know, the wind turbine people really came back and said, oh, let's don't even be talking about what we're doing until you guys want to start addressing all of these other issues. And they're kind of right? So as far as aesthetics, I think, you know, if you moved somewhere so you could have a view like of the desert, like on the bottom picture of those big saguaro cacti, you don't want to look out your window and see those wind farms. And I get that, and there's really no solution or compromise that I can think of, you know, that comes up to that. So the way they look is an issue, and so if it's a beautiful view, that could be a problem. How do they actually work? One of the videos you already watched kind of shows you how it worked. The big blades are basically turning a generator. There's a little tiny turbine in there that turns, and that's called the nacelle, and that's what generates electricity. And so they're basically converting the kinetic energy of the wind, the movement of the wind. And so this is a really easy way to generate electricity. And a lot of these towers are really tall. They're 260 feet tall, and usually they will install a whole, a bunch of them, several hundred of them together in one area. That makes more economic sense to do that than just put one here and one there. So they usually will do a lot. And so these are here and they're working well. A lot of places, including in Ohio and Indiana, have lots of these, and I've seen some in other places too. You might have wondered, can they ever move too fast or spin too quickly? And the answer is yes, they can. So if there's a big storm or a wind event, these have a computer control in them, and it will actually turn them off, and it will lock the blades down in a fixed position so they can't turn too quickly. So they're already set for windstorms. They can deal with that. And so offshore is sort of a new venture for these wind farms. There are a lot more wind speeds over the top of water than on land. And so, but the problem when you do this, you're dealing with ocean water, salt water, and all the corrosive effects of the salt water. It's way more expensive to install these and to maintain them than it would be on land. But in some places, right, if the area is too congested with housing and development, you don't have enough room to install a huge wind farm, but you might have the ocean nearby. And so in some areas, this is happening. The first one of these was installed in the United States just a couple years ago. That was installed off the coast of Cape Cod in Massachusetts. And so that's what that wind farm array looked like there. So there are a lot of benefits to wind energy. There are no emissions at all once it's installed. And so that then prevents all of those greenhouse gases, carbon dioxide, sulfuric oxide, nitrous oxide, even mercury, from being released. And so it is also way more efficient than a lot of the conventional power sources like burning oil or coal or natural gas. It produces 20 times more energy than it takes to actually consume those. Just a second, my dog has decided to bark at somebody. Sorry about that, everybody. My dog does not like the Amazon delivery person, so she always barks whenever they come. And so we were talking about how much more energy efficient wind power actually is. It also uses a lot less water than conventional power plants do. And local areas, even small areas, can become very self-sufficient by using wind turbines. Farmers and ranchers, they can actually lease their land out to these consortiums that run these wind energy farms, and they can still use the land to grow things on. They can use the land for to graze livestock on, and so this is kind of a win-win for a lot of people. So how much of the country in the United States is actually generating? What are the capacity here for generating? Mountainous regions have the highest wind speeds, and they can have the most wind turbines, and that should be pretty successful for them. Along the coasts as well, we always get a lot of wind coming in off the ocean. That would work very well. And so over on the right, you can see it's divided up by the different states, and this is the different states' capacity, how how much energy could they make by wind. United States, you can see kind of United States has some different areas, but the state that jumps out to me the most is Texas. It has one of the largest capacity for generating wind. However, there are not very many wind turbines in Texas. Texas is noted for its oil and gas operations. And so they have kind of shied away a little bit from installing very many wind farms there, but that's actually growing. So, but Texas is still, a very big oil and gas producer, and so I don't know how quickly they're going to adopt green technology. Let's jump to geothermal energy, and this is basically using the heat of the earth as a form of energy. And there's a big geyser, and so that's steam that's shooting up in the air there, and so that was water that was heated up by the magma of the earth. This generates completely by a natural process. There are two kinds, well, actually three kinds of geothermal energy we're going to talk about. There's dry steam, and this would be amazing if we had more areas that had dry steam. This is very rare. It's the cheapest source of geothermal energy because you can use that steam directly to turn a turbine and make electricity. But unfortunately, most places have wet steam, and there are a lot of contaminants, a lot of very corrosive contaminants in that steam, and that has to be separated out before that steam can actually be put to use. And then lastly is just hot water. And it's very common to have areas that have, quote, hot springs. And so that these are areas where there's just, warm baths and hot springs that people can enjoy and use for whatever. Most of the time the water isn't hot. It's just, very, very warm. And so there are hot springs scattered around the whole world that people have enjoyed and used before. So why do we get this? There's the link showing you how geothermal energy works. If you can click on that and watch that. Down below, you see sort of the Earth's magma, and so in certain places of the world, the Earth's crust is a little thinner, and so that's where the magma can kind of intrude and warm up things, and so we can have again different kinds of steam, different kinds of geysers, and then these hot springs. So this is a very simple drawing of a dry steam use of geothermal, and you can see here that it's actually being used directly and turning a turbine and making electricity. And again, this is wonderful, but it's pretty rare. There's not very many places around the world that have dry steam. This is closer to what most geothermal plants actually look like that are around the world. I've gotten to visit a couple of them. New Zealand has a lot of these. They're kind of scattered all over the place. And so you can see there's the, quote, production well where the steam, the wet steam is being brought up out of the ground with, it's drilled, and then the steam comes up and it's controlled. It goes into several different filters. I mentioned to you there's a lot of corrosive compounds in this. One of those is sulfuric acid and sulfur gases. These areas really smell. They always smell like rotten eggs, and it's really kind of unpleasant to be around these areas, mostly because of those sulfur smells that are coming up. Once those impurities are taken out of the steam is used directly to drive a turbine. Over time, the steam then is cooled down. It, quote, condenses, and then that water is pumped back in. It's injected back in into the fault area to make sure that this well doesn't, quote, run dry. And so that's how most wet steam facilities actually operate. And so hot springs have been used historically for all kinds of things: bathing, cooking, heating. There's a lot of medicinal properties associated with hot springs. Geothermal energy increased by 40% in the 1990s. People really grabbed a hold of this technology and said, well, the earth is already providing all of this energy. We just use it for a few, 2.8 million homes per year. That's how they obtain their electricity in the United States. But other places are much more. So lots and lots of places in New Zealand use this. Lots of places in Iceland, for instance, use geothermal energy as well. And there are a lot of new technologies that are keeping the prices down. And so lots of places are kind of adopting new ideas about using geothermal energy. This is a map of sort of the resources of the United States where most of the wells are located. You can see most of those are out west where it's very geologically active. And so these are where the larger plants are located. So locally in Ohio, and even at Miami, Oxford, they have installed some geothermal ways of heating and cooling buildings. The newer, bigger dorm that's in Oxford, as you come into Oxford, across from where the horse stables are. For some of you, you know exactly where I'm talking. Other people haven't visited Oxford in person. There's a new set of dorms there, and they use only geothermal. And so what they're using here, and for people who actually have heat pumps, that's a form of geothermal energy. And so what they're using is the top, let's say 10 feet of the Earth's surface, that tends to stay between 50 and 60 degrees all year round. So there's a series of tubes or pipes that are buried in the ground, and they're filled up with liquid. And then there's something called a heat exchanger that's installed in your home. In the wintertime, the heat is removed and pumps that into an indoor system. And in the summertime, the process is reversed. So in the wintertime, you might be going, well, wait a minute, 50 to 60 degrees, that's not very warm. I like my house warmer than that, and most people do. But think about what that means then. Your secondary furnace then is pulling that 50 to 60 degree air into your house, and it only has to raise it then by, let's say, 10 degrees to get your house up to 70, or 20 degrees if you start with 50 degrees. So you're just having to pay for a little bit of energy to bump that up just a little bit to make your house more comfortable for you in the wintertime. Sometimes in Ohio it can be 0 or 10 degrees outside, and you use a whole lot more energy than raising your home's temperature, bringing in that cold air into your furnace at whatever ambient air temperature it is than this. And so this is a very big cost savings. These units are pretty expensive to install. We have some friends that have one of those in their home, and it keeps it very, very comfortable for them. Their utility bills are so low, but the upfront cost of the system was pretty expensive. For the summertime, their cooling is almost free because 50 to 60 degrees, air in the summertime feels pretty great inside your house. So this is a really good way of cooling things for sure. There's the advantages. There's a lot of good advantages, right? And so the problem is that, that it doesn't quite work everywhere equally, but again, these are all the advantages. So there's hardly any emissions here at all. There's no fuel required. There's no fluctuations. The earth always stays exactly the same, right? It's always the same temperature. It doesn't need much land space, so it's not like having a huge solar array or a huge wind farm. You use a lot less land for that. It's never going to run out, and In some areas, depending on what the heat source is and how this is being used, the costs have come way down. A lot of these areas are built underground, so then you can do whatever you want to do above ground, and you can still use that land. And so the last geothermal that I showed you is available from most places. So and that technology is getting better and better. The disadvantages is that it can be non-renewable. It's possible if you remove enough of that underground steam and it's lost, it's not captured and re-injected, then those geysers over time will lose their energy. So the water has to be collected and put back underground. There are only a few, and in the eastern United States, there are not very many accessible deposits for this. There's plenty in the west, but not in the east. Some of the trapped gases and substances, like hydrogen sulfide and arsenic and other trace metals, those can be released during extraction. And so they are getting better and better at capturing these things and filtering them. But wet steam inherently has a lot of these things with it. And I mentioned to you before about heat pumps. A lot of people in Ohio use a heat pump, and they're just able to capture the difference then between the difference in the soil and the temperatures and the air temperatures. And so a lot of our ground source heat pumps or geothermal heat pumps do a really good job in moderate climates to heat the buildings when it needs to. And they're certainly very, very efficient for cooling as well. About 600,000 homes have ground source heat pumps already. So this is not that uncommon. This kind of shows you how that works. In this case, it's showing you the pipes laid underneath the building. And outside the building. Sometimes these are done vertically, and then that way they don't take up as much footprint, but they certainly do reduce electricity and emissions quite a bit. Now, lately, new folks are trying to figure out more and more green technology, and so there are some enhanced geothermal systems that are being used, and basically water is put into deep holes, and water maintains its temperatures more steadily than does air temperatures. And this can be used in lots and lots of locations. But some of these geothermal systems could be responsible for triggering minor earthquakes. So this is not available for everywhere. Just some places are using this. So let's talk about ocean power or wave power, wave energy. This is the energy that's derived from the motion of the oceans and the seas and the waves. They use turbines or water wheels, and they can capture then the tides or even use the thermal currents that are actually in the oceans. And so some of this is really exciting, especially for all the huge population centers around the world that are located on the oceans. So there's such a thing called a tidal stream generator, and this uses the kinetic energy of moving water to turn a turbine. It's really similar to wind turbines. And then there's a tidal barrage system that uses the difference in potential energy between the tides, between high tide and low tide. So this is one of the last ones, the tidal barrage systems. And so what they've done is they basically have trapped the high tide here behind some gates. And then as the low tide is at its lowest, they will release that water, and the movement of that water rushing through will turn turbines and make electricity. So tides move in and out twice a day with the sun and the moon, and so this is a pretty steady way of generating electricity. The wave energy is newer, and this is one of those kind of new technologies that's being piloted, where they're actually trying to use the Gulf Stream or the ocean currents. And there have been some underwater turbines that have been erected off of Europe, and they're piloting those. And so this is a really interesting way of changing kinetic energy into electricity. And so that's what they're doing there. So as far as the actual ocean power, it's non-polluting. It is totally renewable because the waves are always going to be moving in and out. The disadvantages is that it could potentially change if you're using this like tidal barrage system. It could reduce the range of the tides, and on a local, just locally where these are located. And so that can reduce the tidal flow. And this is a really important way for nutrients to be exchanged back and forth. And so locally where these have been installed, that could impact the ecosystem. It certainly does change the sea levels, and there's a risk of killing aquatic organisms. Organisms are caught on one side or the other of these gates. When the gates are opened, there is an extreme rush of energy, and so that could cause some of the creatures to not be able to make it. Hydropower is a form of water energy, right? And we've talked about dams before. There's a picture of the Hoover Dam, and so it's holding back Lake Mead. And as the water is lowered, it turns the turbines down below, and it generates quite a bit of electricity. And so again, basically, we're harnessing the energy from moving water, and it usually does turn a turbine, and this is the largest source of renewable electricity right now. Worldwide, this is the largest source of renewables. It accounts for about 24% of the world's electricity and about 10% of the United States electricity to date. There's how a hydroelectric dam works, and you can kind of see where the intake is. The penstock leads the water to the turbine, and then lastly you see the powerhouse and the generator there, and then the water is released. So the advantages are it's clean, it's inexpensive after the initial construction. The initial construction of these dams is very expensive. They're also expensive to maintain. They can totally be controlled, and we have water reservoirs as a benefit that helps with flood control and recreation. These are available to many less developed countries. They've already installed and are using hydropower. There's the dam in Brazil, and that's the second largest generating capacity. It accounts for 12,600 megawatts in the world. The disadvantages, we've kind of talked about these before, so I'm going to go through that really quickly. It does drastically alter the ecosystem. It's especially important if there are migrating fish that swim upstream, like salmon. And this also alters water availability downstream, so people can change the water currents for downstream. This is one of the solutions for the migrating fish. This is a fish ladder. And what would normally happen in a wild river is the fish would be swimming upstream. They would encounter obstacles like fallen logs and rocks and debris, and they jump over those. And so lots of places where they do have migrating fish groups, schools, they'll install the fish ladder like this adjacent to the dam, so the fish can have an opportunity then to quote swim upstream and then get over the dam, so it doesn't block their migrations. And so again, salmon in the United States need this in place, so their life cycle isn't interrupted by the dams. So there are some other issues with hydropower. At the base of these dams, a lot of silt and eroded material can accumulate, and so dredging has to be maybe required, usually is required. Not all the time, but let's say every 8 to 10 years, a lot of this stuff will need to be removed. And so if you don't lessen and take out some of the silt and do the dredging, then there's a lot less generation ability, and it also lessens the flood control ability for these dams too. So that's what goes into the cost of maintaining some of these facilities. We've talked about people being displaced and wildlife being displaced, and that certainly is a disadvantage, and that's an important factor to remember about hydropower. Sometimes these dams actually collapse. And when a dam collapses, it can be catastrophic. There can be an awful lot of people injured, and so that's one of the reasons why some of the dams are being removed, is because there's a risk of them collapsing. So let's move into biomass energy. And biomass energy is where organic matter is actually used as fuel. So sometimes it's where the crops are being grown particularly for this. And then also it could be where you have extra biomass, and then, as a side, it ends up getting burned as fuel. This is totally one of the oldest sources of energy. If you think about people, having a campfire or a fireplace in their home, this has been around for a really long time. It supplies about 14% of the world's energy. A lot, more than a third of the less developed countries' energy relies on biomass energy. In some of the poorest countries, 90% of their energy comes from biomass energy. In modern countries, more developed countries, it only accounts for about 3% of our energy. So this again can be crop residue, it could be wood, it could be animal dung, animal waste. It could be crops grown specifically for energy, like in Brazil. There could be fuels made from the alcohol of plants, like ethanol. And then lastly, biogas. So as things are breaking down and decomposing, they release a lot of biogas. And so I'll show you some pictures of that, how that works. So, for biomass energy, again, either the stuff is being collected or it's being actually grown for this. In some municipal areas, solid waste is actually collected. If there's any kind of construction or demolition, anything that could be incinerated is incinerated or combusted, and that's used to make electricity. The advantages are it's accessible, it's inexpensive, it's relatively clean, except for the transportation and fertilization costs, especially if you're growing a crop for biomass energy. You have to account in all the fossil fuels that are being used to be able to grow and raise and transport that crop. There are disadvantages. It could be overexploited and actually become non-renewable. So if an area is being logged, particularly for biomass energy, certainly that's deforestation, and that could quickly we could cut down everything. A few years ago, when the big earthquake hit Haiti, the only trees left at the time on the entire island were trees in the presidential mansions complex. And that's because the Haitian people had previously cut anything that could be burned to be able to boil water or cook. Pretty much all of their biomass had already been burned, and so there were only a few trees left there. This can result in, obviously impacting the fertility of the land because the nutrients are removed from the soil, right? You're taking the plant with all those nutrients and you're moving it and taking it somewhere else. It can drive up the price for food because instead of the food being used to feed people or even to feed livestock, it's just being burned. And so that could tend to cause some of the food to increase in price. And again, some areas are actually deforested on purpose just to grow crops for biomass energy. That is what's happening in Brazil right now. This is an alternative for maybe growing corn or even deforestation. This is called switchgrass. And this is a former mine land area here that's been coal mined. And so they're growing the switchgrass here because it grows incredibly fast on very poor, nutrient poor soil. And it's possible that that could be baled up and then used as a form of energy. So that one's being tried now. This is the Brazilian rainforest. Everything that you would see in this picture now is all sugarcane. Brazil is trying very hard to become energy independent. And the way they decided to do that is they decided to deforest the rainforest and grow sugarcane and then turn the sugarcane into ethanol. And so that's what's happening in Brazil. As far as the solid waste of stuff that people throw away, a lot of the refuse that's produced in the United States is biomass fuel and can be burned. Anything that's combustible can be burned to produce heat and electricity. And so some places are using biomass energy still. This huge mound of debris is actually Hurricane Sandy debris. So when they had that enormous hurricane and flood and fires and all the things that happened, all of those buildings were shredded and all the wood was collected, and that's being used now in this incinerator to make electricity. This is a diagram of something called a biogas digester. And so animal waste or even human waste is stored in ponds and then it's sealed with a cover. It's kind of like a big balloon. And as the decomposers get very busy breaking down all those solids, then biogas is collected above. That can be used directly. That's just, quote, natural gas. I know people don't like to think about it this way, but it can be used directly to make electricity or run a gas grill or anything else that you would want to do. And so that's what biogas is. As far as the overall advantages of this, it really prolongs the life of landfills. So instead of dumping and burying everything, we can actually turn some of that into energy. Methane that is currently trapped inside of landfills, that can also be used in place of oil. And so over on the left-hand side of this picture, you see a closed landfill. And so it's producing a lot of methane, and those are little methane wells there that are trapping the gas, and that methane can be used. There are quite a few disadvantages of using biomass energy. First off, it's not economically feasible in lots of locations, right? You can't really do this inside of huge cities very well. It can also hamper recycling efforts. If people know that you're turning your garbage into electricity, then they're not going to be as careful with pulling out recyclables. There are a lot of contaminants, especially if trash is being incinerated, if it's not being separated out, if you're just, gathering up everybody's garbage and incinerating it, that can definitely lead to a lot of air pollutions. And so the last little bullet point here says NIMBY, which stands for Not in My Backyard, most people do not want to have a biomass, anything associated with this. They don't want these kind of incinerators near their home. This is a old photo of a big trash burning power plant that was in Columbus, Ohio. And this facility had an uphill battle for the longest time before it was built. And after it was built, it was only in operation for not even a decade. And the citizens that lived in this area were doing a lot of air quality monitoring, and they were able to show that toxins were being released on every day where this plant was incinerating garbage. And so it actually ended up being closed and demolished. So having, just saying that we can burn trash to make electricity, it's not that simple, right? So there are some new interesting biofuels that are being developed. And so other crops and crop residues, including wheat and sorghum, sugar beets, hemp, grasses, all of those could possibly be used as biofuels. We don't have to just do corn and make it into ethanol like we do in Ohio. Algae is, and that's what the photos are that you're seeing here. This is in a small lab. All of those they have different strains and types of algae growing in those containers. They produce lipids. Lipids are oils and fats, and that can be converted into biodiesel. The carbohydrates that are part of the algae, those can be fermented to make ethanol. And the algae could be grown in ponds or tanks or in something called a photobioreactor. They grow very fast, and they can be harvested every few days. So in some areas, this might be a really new, interesting way of getting enough biodiesel and ethanol without using land, right? These would be growing in aquacultures. This is a picture of that switchgrass that I showed you earlier. And a lot of the ethanol that's used as gasoline additive, it's produced from structural plant materials like the corn stalks of corn, and it doesn't have any food value. So a lot of this would be considered to be waste products, and it can be converted over into ethanol. And again, anytime you see a word that ends in OL like that, that means that that's some kind of alcohol. So a big question here, is bioenergy carbon neutral? In principle, it is, but because photosynthesis actually removed carbon, but then when it is incinerated, then carbon is released again. So it's not actually carbon neutral, especially if deforestation is happening to be able to grow these bioenergy crops. You also have to take into the account of all the fossil fuels that are used to grow these plants, the tractors and the fertilizers, and certainly all of the transportation that's involved with moving these things from point A to point B. The International Climate Change Policy, the Paris Climate Accord, does not encourage trying to become sustainable by using bioenergy. It doesn't really count as trying to control emissions. So I think that's one of the reasons why Brazil is trying to get away from the idea that growing all of that sugar cane is better than having a rainforest. So it's not really carbon neutral. I think that's a really good place to stop for today, and I'll finish up. There's just a few slides left about some of the newer alternative energy technologies, including hydrogen and fuel cells. So let's stop there, and I'll finish this up on the next lecture.